Hey guys, this is going to take us through lesson 20. So go ahead and open up to lesson 20. And let's take a look at fractions as tenths and hundredths. So remember, we talked a lot about making sure that when we're saying our fractions, when you're saying that denominator number, make sure you get that th on the end. Okay? We don't say 110. We don't say 100. We say 1/10 or 1/100th. Got to have that th on there. All right, here we go. In earlier lessons, you worked with equivalent fractions. This lesson will focus on equivalent fractions with denominators of 10 and 100. Easy peasy. Let's take a look at this problem. Doss is riding his bike home. He has 7/10 of a mile to go. Write an equivalent fraction to show how much Doss has left to ride in hundredths of a mile. Okay, so basically all we're doing is we're making equal fractions. We've done this before. It's been a while, but we'll touch on this way that they want us to do it, and we'll do it the way that I taught you. All right, it says, what fraction does the model show? So let's look at this model. You should be able to see 1, 2, 3, 4, 5, 6, 7 are shaded. So 7. Out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total. You did that last year. You know how to do that. All right, so what is the denominator of the fraction? It's 10. We know that. The distance is given in tenths. Well, you need to find it in hundredths. Hundredths is how many times the number of equal parts as tenths. In other words, how do I get from 10 to 100? You got it. Multiply by 10, right? So it's 10 times. What is the numerator of the fraction 7/10? Top number, numerator, 7. Explain how you could use multiplication to find a fraction with a denominator of 100 that is equal to 7/10. So, we talked about equal fractions, and we talked about the fact that equal fractions are going to be the exact same amount of shading, different size. Okay, so the same shading, different size. So we talked about, this is the way that I showed you, 7/10 is equal to, I want a new equivalent fraction that will get me to 100 pieces. So basically what I'm doing here is right now I have 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 strips. Well, I need 100 to be my total. So what I'm going to do to those strips, see if I can do this fairly equally, is I'm going to cut them again. 1, 2, 3, 4, 5, 6, 7, 8, 9. What did I do there? I changed my size. Do you see that? I changed my size. I didn't shade any more. I didn't shade any less. I just changed my size. So now, if I were to count all these little pieces, there's 100 of them. If you don't believe me, you can pause the video and count them. But there's 100 of those pieces. Now, if you know that each of these is 10, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 pieces in each strip. If you know that each strip is 10, okay, so we started with, let me back it up a little bit. We started with 7/10. Okay, that was before I drew my lines, 7/10. Then I cut my pieces up differently, and now I have 100 pieces. Okay, so my size has changed. I've went from 10th size pieces to 100th size pieces. Well, now how many are shaded? 10, 20, 30, 40, 50, 60, 70. Do you agree? 7/10, okay, is the same as or equal to 70/100ths. All I did was change my size. I just cut them up differently. Now the key here is that I cut them up differently, but I cut them up equally. That's the trick. All of these pieces, now to look at it, I know they're not exact because I'm not a very good freehand. These ones are obviously bigger than these ones. However, they are to get to 100, okay, to have the same amount shaded. If I start with 7/10 and I break it up into 100th size pieces, I'm going to need 70 of those 100th size pieces to make the same amount of shading. That's all we're doing here. So it says, explain how you could use multiplication to find a fraction with the denominator of 100 that is equivalent. Do you remember doing this? How do I get from 10 to 100? Multiply by 10. Whatever I do to the bottom, hopefully you said you got to do to the top. 7 times 10 is 70. Okay? So same thing, just this is the math way to do it. This is the picture way to do it. I'll tell you the math way is going to take you a lot less time. All right, let's flip the page. All right, it says, every fraction with a denominator of 10 can also be written as a fraction with a denominator of 100. The model in the previous page divided into 10 equal parts or tenths. If you split those 10 parts into 10 equal parts, then you have 100. That's exactly what I just did. I colored, or I didn't color it, but I took the columns that were colored and then I just cut them. Okay. When you divide the whole into 100 equal parts, instead of 10, 70 parts are shaded. There are 10 times as many equal parts, so 10 times as many of them are shaded. You can also say the model has 1/10 as many equal parts as the hundredths model, so it has 1/10 as many parts shaded. That's a whole lot of words to say. 1/10, if we're talking about just tenths, 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10. Okay, so 7/10, 7 out of 10 columns, or cut it up this way, 70/100. Okay. You can also use money to think about equal fractions or equivalent fractions with denominators of 10 and 100. So a dime is 10 100ths of a dollar. Think about that. 10 100ths. Well, what is a dime worth? It's worth 10 cents out of 100 total to make a dollar. 10 dimes is $1. So 1 dime is 1/10 of a dollar. You need 10 of them to make a whole. Okay, so if 1 dime is 10 cents, the value is going to be 10 out of 100. If 10 dimes is a dollar, 1 dime is going to be a tenth because you need 10 total to make a dollar. They're equal. It's the same thing. 10 100ths and 1/10 are the same thing. They're both going to give you the same amount. Okay? If I drew my picture, I'm going to use this. What fraction of the model to the right is shaded? Well, I guess it's already shaded. Kinda. Here, I'll make a new one. You don't have to write this. 8, 9. Okay. So if I shade in 1/10, okay, so there's my 1/10. Is that not the same as okay? Now what do I have? I have 10 100ths. Same thing. 1/10 and 10 hundredths are the same thing. All right, it says what fraction of the model is to the right is shaded. Let's show two different fractions to show the amount. Now this one is very, very light. So if you can't see it, it's the first 3. Okay? So if I think of it just in terms of tens, so if I think of this as 1 column, 2 columns, 3 columns, 4 columns, 5, 6, 7, 8, 9, 10. How many are shaded? 3 columns out of 10. That would be equal to, or the same as, how many of these are shaded if I'm looking at the 100th size pieces? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on and so forth. You're going to figure out that there is 30 of those little 100th size pieces. Therefore, 3/10 is the same as 30 100ths. Okay? All right, let's go on to some problems here. Cameron says that she has 4/10 of a dollar. Troy says that he has 50 100ths of a dollar. Together, what fraction of a dollar do they have? Okay, well, we're going to picture it. You can use the picture to help you add the fractions. And you know that 4/10 of a dollar is 4 dimes. And 50 100ths of a dollar is 5 dimes. Just 2 different ways to say it. 4 out of 10 give me a dollar. So there's your 4 out of 10. 50 cents out of 100 cents is 5 dimes because that's 50 cents. So 9 dimes is 90 over 100th, or 9/10 of a dollar. Now, this is the way that the state also teaches this. I'm not a big fan. Here's why. I have been telling you over and over again, add the pieces, not the size. Well, what is happening here? These are tenths, these are hundredths. In the math world, you really can't add those together. I understand why they're doing it. They're trying to show you that they're the same in a little bit different capacity, but I don't like it. So here's what we're going to do. We're going to look at how to change your denominators so that the denominators match and everything works out beautifully. Let's look at this problem here. Let's look at this fraction. 4/10. Well, you know what? I want to make sure that these two are the same, and I can never make 100 into 10, but I can make 10 into 100. How am I going to do that? All I got to do is slice up my pieces. Bam, what'd I do there? It's not 4/10 anymore because 4/10 is the same thing as 40 100ths. Agreed? You can't see that shaded in a little bit. 4/10 is the same as 40 100ths. I didn't shade any more than was already there. I just cut the pieces differently. I cut them into 100th size pieces instead of tenths. So now, look how nice this works out. 40 100ths plus 50 100ths. Same denominators, make Mrs. Reed happy. Add your pieces, not your size. Boom. I don't like what they did here. I think it's confusing. We're going to do this my way. Okay? All you got to do is change that 10, make it into hundredths. All right. So, that's what they did here. I don't like that they don't show, I don't like this visual because I feel like this visual makes you think, wait a minute, where did that denominator come from? Where did the 10 and the 100 come from? Where did the 4 and the 550 come from? This is kind of the breakdown. So it says, what are the denominators of the fractions you are adding? We've got 10 and we've got 100. Are they the same? No. Okay. Complete the equation to find the hundredths equivalent to 4/10. Well, what they want you to do here is they want you to figure out, just like what we did, How do I get from 10 to 100? I have to multiply that 10 by 10. Whatever I do to the bottom, I have to do to the top. So we just found an equal fraction. So we could even get rid of, let me see if I can, there we go. 4/10 is the same as or equal to 40/100. That's just the work on how to do it. Now when we add them, 40 plus 50 gives me 90/100. So together, Carmen and Troy have what fraction of a dollar? 90/100. Explain how you can use equivalent fractions to add a fraction with a denominator of 100 and a denominator of 10. Well, that's exactly what we did here, and it's exactly what I showed you before. When your denominator is 10, you can multiply your denominator and numerator by 10 to find the equal fraction. Okay, if you need time to write that down, just pause the video. So by multiplying by 10, that's going to give you an equivalent fraction with a denominator of 100. All right, so let's try it. Giselle spent 7/10 of her money on a book and 10/100 of her money on food. What fraction of her money did she spend altogether? Well, I don't like that they didn't give me space here, so I'm going to make my own space. 7/10 plus 10/100. Okay, and this is how I want you to set it up too. So I can't make my 100 into a 10, but I can make my 10 into 100. So I'm going to put this number All right, how do I get from 10 to 100? Multiply by 10. Whatever I do to the bottom, I have to do to the top. So 7/10 is the same as or equal to 70/100. These are the same. Okay. All I wanted to do here was make the denominators the same. I can't add 10th size pieces and 100th size pieces because they're not the same. 100th size pieces are much, much smaller. So I had to make them, I had to cut up my 7/10 to make it the same size so I could add them together. So 70/100 and 10/100 is going to give me 80/100. Okay. You will learn next year how to reduce. We're not going to do that this year. So we can just leave that at 80/100. All right, the winning car in the race beat the second car by 19/100 of a second. The third car was 4/10 of a second behind the second car. How much did the first car beat, or by how much, sorry, did the first car beat the third car? All right, so we've got 19/100 of a second. Okay, so the winning car. Now, remember, if you need to draw a picture or visualize what you're doing here, do that. Make sure that you do that. Okay, so we're talking about cars here. And this is going to be this is kind of my silly, there's my checkered flag. All right, so here's the winning car. Oh, I should probably do the rest. So there we go. All right, so there's your winning car. it beat the second car, so here's the second car, by 19/100ths of a second. So this is going to be your, this is so you can visualize what's happening here. The third car was 4/10ths of a second behind the second car. So here's my third car. My mustaches are not very good today. This is 4/10ths. So we want to know, how much did the first car beat the third car by? So we need to know this distance. So we're going to take 19/100ths and add 4/10ths. Right away, oh, denominators aren't the same. We've got to make them the same. So we're going to turn that 10 into 100. Keep the other one the same. That 100 that's already there is beautiful the way it is. All right, how do I get from 10 to 100? I multiply by 10. Whatever I do to the bottom, I have to do to the top. 10 times 4 is 40. Now, add your pieces, not your size. So this would be 59/100ths. Okay? And that is the end of our lesson 20.